Welcome to this Frequency Matters podcast. I'm Pat Hindle, and today I'm talking with Iyad Tarazi. He's CEO of Federated Wireless. Welcome, Iyad.
Thank you, Patrick. Thanks for having me.
So Federated Wireless is about providing innovation and services that connect people, businesses, and industries to the future. The company is a market leader in shared spectrum, making deploying and managing new 5G private wireless networks simple, affordable, and accessible. So can you give us a little bit of an update on the FCC auctions about the automated frequency coordination in 6 gigahertz for the use for private wireless networks?
Sure. In short, there actually is no auction for 6 gigahertz. The 6 gigahertz band, which is quite a large band, it allows for shared use. So there's a lot of different deployments that can go in it. Wi-Fi 6E and Wi-Fi 7 are probably the ones that people think about the most. You can also do very low power deployments in it for things like, augmented reality type devices, or even very small devices that can be used for simple home electronics type usage. The band also allows for 5G, unlicensed 5G or standalone 5G deployment as well. It has in it incumbents. These incumbents are utilities and operators and microwave users that some of your audience are that have used this band for a while to do point-to-point deployments, and I want to make sure they're protected. And all of it is governed by a set of rules that the FCC has created with our help. We started engaging with the FCC about 5 years ago to help them model what this band would look like, help them design the regulatory rules, build simulation tools for them on the cloud to be able to run different scenarios, specifically around how we protect the incumbents, how do we support the existing users, how do we open up the band as much as possible, how do we create the highest power and best utility for everyone, but also limit interference to the minimum. And these rules resulted into a series of rulemakings. And as probably some of your audience have followed this, there was some even court challenges along the way and settlements and work with the FCC to keep refining it. And now we have a set of rules that allow for respectful and proper sharing. We have had spectrum sharing cloud system that we've had now in commercial use for over 6 years for the CBRS band. That's a citizen broadband. It has on it over 200,000 nodes now in deployment. And we've been operating more than 500 customers on it for years now. It is highly available, proper support, and all the activities around it. And what we've done in the last 2 years is we ported all of that experience and knowledge and capability and scale into an equivalent product for the AFC, which is a cloud management system for how you interact and get access to the 6 gigahertz band. That system has been under testing by us for over a year. It's now been under testing with the FCC for a while. We had to demonstrate to them that we can meet all the technical requirements. And as probably as some of your audience know, we've been going through now the public trials where we're out there doing testing in public and are open and supportive of requests that we get in terms of how does it work and how does it impact me and what you're seeing. And we're within a very, very narrow shot of being able to get to certification to begin to operate here in the next couple of months, maybe even earlier. So that's sort of how this band is working. The band is turned into a sharing band. We've helped develop the rules. We've helped build the system. We have the most operational and rigor-tested system in the industry. And it's one now that we're going through the final testing, and the result will be another very large sharing band that everybody can take advantage of within the rules and be able to get access to high quality spectrum at high power and do things they've never really been able to do before in the frictionless model, all through APIs, all through easy support with very, very little cost, with no need for long applications and lawyers involved. All of the can be done quite simple once their equipment is interoperable with our system. That's maybe the long answer of what the auction is, because there's no auction, Patrick. Yeah. That's the reason I had to explain that.
That's a short answer.
Yes.
So you talked about this sharing. It's AFC, automated frequency coordination. What exactly is that? How does it work?
It is a cloud system. that has APIs that equipment can dip into. Maybe the best analogy is think of it as an Airbnb for spectrum, where it's able to track what spectrum channels are open, which one are used by whom at all times. And when you are beginning to set up your link in whichever technology that you're using on this band, you're invoking a piece of code in your equipment that will automatically come to our cloud system with a predefined set of rules to ask, this is where I'm going to be. This is how much power I'm looking for. Can I have, how much spectrum can I have? Which part of the band should I operate in? What kind of interference should I expect? Can you grant me that spectrum? Sort of like searching for, the dream vacation house before you go on vacation on Airbnb, and you'll get the results back, and the equipment is able to use these results to pick the right channel based on the way the equipment is configured and the user settings. And voila, you're able now to get access to that channel immediately and begin to operate. So the FCC is a cloud-based management system that has access to the entire US, that knows who's who and what they're doing, and is able to do real-time interference calculation. So it's a real-time heat map that will allow us to calculate what's available where, when, and make sure we allocate in an orderly manner so that by using an AFC, you're able to get to what's called standard power in this band. Standard power means full power operation to give you roughly 6 times the power you would get if you don't have standard power. That is significant. And it is, for some users, we've calculated to be 10 times the coverage that they would get with standard power than without it. So being able to have proper coordination and real-time analysis, real-time performance, real-time heat maps, being able to understand who else is using the band for what, being able to understand and react to interference reporting from equipment, which is what the AFC does, allow everybody to get a lot more out of the band because we're able to pack the seats on the bus much tighter.
Wow, that's a huge improvement. Very important going forward, I see. So, what exactly technology are you using and how do you accomplish this? What kind of products do you provide?
Sure. It's all on Amazon cloud. So it's completely cloud native. It is built to be able to, we use roughly about 200 products from Amazon, everything from front-end management to load balancers into API management, databases, mainly from Mongo and other users, authentication, management of data security, management of protecting user data. And then we crunch this massive amount of data on a regular basis and be able to provide data back. So we get data in from an piece of equipment, like say a Cambium box or a Tarana box or a Cisco box or HPE. And then we crunch the numbers, give them back where they need to operate. And we also offer our users a management system run off of ServiceNow that has all of the case data, reporting, being able to see where the equipment is, how it's performing in a real-time basis, be able to request additional data or request additional systems, be able to manage their account and know how they're dealing with us. We do all of that as part of the system. As part of the service we provide as well is interoperability testing with their equipment makers. We've already done full interoperability testing with the major users, equipment makers in the enterprise space. These are the Ciscos, the HPEs, and a few others. And now we're in the process of doing interoperability testing with the fixed wireless space, the Cambiums, the Taranas, the Telrads, and others, Mimosa. So if you have a piece of equipment that you're going to use with our system, we will have already done the interoperability testing ahead of you, made sure your equipment work. We keep good relationships with all the equipment makers as part of our service, make sure it always works. We update our software when they update their software and vice versa. We coordinate with them if we run into a problem. We run a full knock in order to make sure that all the links are being monitored at all time. Spectrum access is there all the time. So the service we provide is access to spectrum, compliance with the FCC rules, protection of the other users so that we don't create a problem for anyone, interoperability with the equipment makers, access to network status and support for how your account is running and where you are, and data on it, onboarding and training for people that need it to understand how it goes, and evergreen support, including NOC, to make sure you're up and running and you have high quality service going forward.
Wow, it's a very comprehensive solution. And so you mentioned that you provided responses to inquiries regarding channel and power level availability as part of the ongoing AFC public trial. Can you tell us, how those efforts resulted and, kind of what's the next step as you're ready to launch?
Sure. We've gotten literally hundreds of inquiries. All our testing is within what we expect it to be. The public trial it actually closed a couple of weeks ago. What we're doing right now is reconciling all these responses, and we're comparing them and working with other applicants for this process, other AFC providers. And then we're working to reconcile that about the expectation of the incumbents, and what inquiries we got. A lot of the inquiries we got are mostly from the incumbents. So far, discussions are going quite well. And expect that we're going to submit our final report to the FCC in the next week or two. And then the FCC will take that and decide how to actually prepare that for public consumption.
And so those are the next step to certifying you, even to support commercial Wi-Fi 6E standards and outdoor operations to protect the incumbents.
Yes. So again, that's our number one job, is protect the incumbents. And so we've done two things. We've done the lab test reports that we've sent to the FCC in October so far, well within all the expectation. We're preparing our public trial report to send the next couple of weeks. With both of these reports in the FCC's hand, they should be ready to certify us potentially as early as December or maybe very early next year. We have been operating in pre-commercial mode now and doing testing for about a year. And we've done not just interoperability testing with the lead equipment makers, but we've also done performance testing, load testing, security testing. So we should be able to start operating commercial service as early as December this year.
Wow, that's great news. So let's talk about the future. What are some of the interesting DoD implementations that offer a future peek into where the enterprise private wireless market is heading?
Yeah, so the enterprise private wireless, so we operate another band, as you know, which is CBRS. That's 3.45 to 3.7. 3.55 to 3.7. That band is one that is being used primarily for 4G and 5G. And there we've had hundreds of private wireless deployments. The use cases that are gaining the most traction right now in that space are DoD applications. For example, we have one deployment in a big marine base where we have over 1 million square feet, all robotics automation, all with CBRS. It's one of the biggest 5G deployments for the Navy and really for the DoD services. We have deployments beginning now in another Air Force base, another deployment that's about to start in a Navy base out in Guam. We have deployments as well in higher ed. Probably our biggest one is Cal Poly. That's a university in California that is pioneering a lot of the work on private wireless and on something called neutral host, which is the ability to do public-private interoperability between, a private wireless solution with CBRS and one that allow you to roam back and forth with the operators, T-Mobile, AT&T, and soon to be others. We have also deployed and about to finish deployment school systems where they have funding to support their students who don't have access to the internet. We're deploying public networks out there, similar to what you would see for a public Wi-Fi network type, but with 5G and 4G, connecting it to laptops, giving laptops to students to be able to have coverage outside of the school and be able to interact with the school systems. And we have other deployments about to start in airports and some in manufacturing to help with automation. That's what the private wireless space is beginning. A lot of it is 4G and 5G and CBRS. What AFC and 6 gigahertz offer as well is the ability to add additional capacity to it. Capacity in the Wi-Fi space, Wi-Fi 6, 6E specifically, and 7. We should expect to see outdoor deployments with Wi-Fi once you get 6E. I do think that the top deployment potential for AFC and 6E will most likely be point-to-point and point-to-multipoint fixed wireless outdoors, or IoT and automation outdoors for Wi-Fi, where people have tried to use Wi-Fi for robust outdoor deployments in a 5G manner, and they haven't been able to get there. And so they want to maintain the Wi-Fi network, but they want to get robust, high-quality networks outside. I expect that that would be one of the applications. The other application we will see is augmentation to microwave point-to-point type systems, but with 6 gigahertz solutions. These are potentially equipment from Tirana or equipment from Cambium that will begin to include 6 gigahertz in the roster spectrum that they've been using in these solutions today to extend coverage and add capacity and improve performance with really low cost spectrum. So I expect that we're going to see quite a bit of these types of solutions. But every time we think we can predict what people will do with the new technology, we're always only half right. So there will be new things that we haven't seen. I mean, I've seen now car factories being deployed with 5G. I've seen ports that have automation with private 5G with CBRS, but certainly look forward to see what other applications will develop beyond CBRS into AFC and 6 gigahertz band.
Well, I think bringing cloud services to wireless applications is a big mega trend that you pointed out earlier this year at Mobile World Congress Barcelona. I saw your interview there, and it was really a great interview with the AWS product manager there. So I look forward to maybe catching up with you in Barcelona next year and continuing the conversation. I think this is really a lot to look forward to.
Thank you, Patrick. And we should be announcing our commercial launch soon and be able to support. And if anybody wants more information on Federated and how we're supporting this market, I'm sure they can go to our website and see the right information or can let us know. And we're happy here to support anyone. Thank you, Patrick.
Thanks, Iyad, for talking with me today about automated frequency coordination and bringing the cloud to wireless. We'll be following this technology and check back with you in the future. To our listeners, you can find more podcasts at podcast.microwavejournal.com. Thanks for listening.